You think you know storms, rain, wind, maybe lightning, but what you're about to hear sits in a different category. We're talking about storms that reshape coastlines, storms that collapse cities, storms that turn day into night in seconds. These are the megastorms, and every single type has its own signature of destruction. Some spin winds past 300 miles per hour. Others stretch moisture corridors longer than the Amazon River carries water. A few drop atmospheric pressure so fast they create their own category of violence. Which ones are real, and how do they actually kill? 872 millibars central pressure. That pressure reading sits just 2 millibars above typhoon tip from 1979, which held the global record for 40 years. Patricia wasn't just strong. It intensified from tropical storm to Category 5 in 24 hours. 85 knots of wind increase, 100 miles per hour gained overnight. The eye contracted to 8 miles wide. Inside that eye, pressure gradients hit 24 millibars per nautical mile. Ships measure these things. Hurricane hunters fly into them. The aluminum fuselage groans. October 23, Patricia peaked around noon UTC, 150 miles southwest of Manzanillo, Mexico. The storm looked like a buzzsaw on satellite. Cold cloud tops, perfect symmetry. By 6 that evening, Patricia made landfall near Cuixmala, Jalisco, still Category 4. 150 mile per hour winds. The damage, less than forecasters feared. Mountains broke the circulation, but 8 people died, and Patricia proved what's possible when ocean heat meets low wind shear. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from the National Hurricane Center's official post-storm analysis published in 2016, and peer-reviewed studies in the Bulletin of the American Meteorological Society from October 2025, examining rapid intensification. Mechanics in the Eastern Pacific Basin. Now back to the information. Nobody saw it coming, not really. The Weather Bureau in Galveston brushed off reports. They didn't realize the threat. The storm surge hit 15.7 feet. The highest point on the island was 8.7 feet above sea level. Do the math. Water covered everything. 130 to 140 mile per hour winds. The anemometer blew away at 84 miles per hour sustained. After that, they could only estimate. When it ended, 8,000 people were dead. Official count. Some estimates go to 12,000. 20% of the island's population gone in one night. 3,500 homes destroyed. 2,636 demolished completely. 7,000 buildings damaged or destroyed total. $30 million damage in 1900 money. Here's what the survivors described. Debris turned into battering rams. Houses lifted off foundations and smashed into other houses. Row after row falling. 2/3 of the city destroyed. People trying to reach shelter struck by flying bricks, lumber, slate from roofs decapitating victims. Bodies everywhere. So many they couldn't bury them all. They burned them. Pyres on the beach for weeks. Isaac Klein, the Weather Bureau manager, warned people the morning of September 8th. Drove his horse and cart along the beach. Told everyone to move to higher ground. But where was higher ground on an island that maxed out at 8.7 feet? Klein's own wife died in the storm. He saved his 3 daughters. His brother Joseph helped. They sent telegraph updates until the lines went down. By 6 p.m., sustained winds hit 100 miles per hour. The station's instruments were blown away. Within 2 hours, winds exceeded 130 miles per hour. They also razed the entire island, dredged sand from Galveston Bay, lifted buildings, lifted streets, lifted everything by as much as 8 feet. 1915. A Category 3 hurricane tested the seawall. 120 mile per hour sustained winds, 16-foot storm surge. The wall held. 6 deaths in protected areas, 42 deaths in unprotected portions. Compare that to 8,000. The seawall worked. Today it stretches 10 miles. Galveston learned the hard way. And it's still the deadliest natural disaster America ever faced. More than all the tropical storms and hurricanes that have struck the United States since combined. Think about that. One storm, one night. September 8th, 1900, more deaths than 325 tropical systems over the next century. Before Patricia, another storm held the wind speed record for the Western Hemisphere. Typhoon Haiyan, November 2013, Philippines. The Joint Typhoon Warning Center clocked sustained winds at 315 kilometers per hour, 195 miles per hour. That's unofficial because no hurricane hunters reached the exact peak. But satellite data doesn't lie. The Dvorak scale hit T8.0, that's the highest rating. Haiyan made landfall at Guiyuan, Eastern Samar, on November 7, 2013 at 8:40 p.m. UTC. The eye was 28 kilometers wide. The storm surge reached 15 to 19 feet. Tacloban City took the worst hit. Entire neighborhoods vanished. Ships ended up inland. 158 deaths in Joplin, Missouri in 2011 made that EF5 tornado America's deadliest single twister since 1947. But Haiyan killed over 6,300 people in the Philippines alone. Storm surge did most of the killing. Water doesn't negotiate. It just comes. Hong Kong Observatory measured 10-minute sustained winds at 285 kilometers per hour before landfall. China Meteorological Administration put 2-minute winds at 78 meters per second. Different nations measured different intervals, but they all agreed Haiyan was a monster. That's lower than any cyclone ever measured. The diameter, 2,190 kilometers at one point, 1,350 miles wide. That's bigger than Alaska. Tip started as a tropical disturbance east of the Philippines on October 4th. By October 9th, it was a super typhoon. By October 12th, it peaked. Then it curved north, struck Japan as a Category 1 equivalent, killed 99 people between Japan, Russia, and the Caroline Islands. But here's what matters. Tip showed us the absolute floor for sea level pressure in a tropical cyclone. Anything lower and the storm probably tears itself apart. The winds can't organize, the eye wall collapses, 870 millibars is the limit unless physics changes. A derecho. You probably never heard that word before that day. Neither had most Iowans. A derecho is a straight line wind event, no rotation like a tornado, just a wall of air moving fast. The August 2020 derecho started overnight in South Dakota. Thunderstorms that should have died. They didn't. By morning they entered Nebraska. By noon they slammed Iowa. The winds, 140 miles per hour measured at Cedar Rapids. That's EF3 tornado intensity. But this wasn't a tornado. This was hundreds of miles of sustained hurricane force winds. The storm covered 770 miles in 14 hours, 8 states, 4 deaths confirmed. 158 if you count Joplin for perspective. But the derecho killed 4 and injured hundreds. Over 500,000 customers lost power in Iowa alone. Some waited 2 weeks. The Duane Arnold Energy Center nuclear plant shut down permanently. Agricultural damage hit $4 billion. 14 million acres of corn in the path, 3.57 million acres destroyed. The corn harvest in Iowa dropped by half. Grain bins crumpled like soda cans. Semi-trucks flipped. Trees embedded in buildings. National Weather Service confirmed 26 tornadoes embedded in the derecho. But you couldn't tell the tornado damage from the straight wind damage. Both peeled roofs. Both snapped power poles. Both left the same signature. Total destruction. And this is the part that makes you uncomfortable. The August 2020 derecho was the most expensive thunderstorm event in U.S. history. $11 billion, not a hurricane, not a tornado outbreak. A thunderstorm complex with a name most Americans didn't know. Not gusts. Sustained hurricane winds over land. The Storm Prediction Center missed it. They upgraded the forecast the morning of. Too late. By the time warnings went out, the derecho was already flattening Iowa. And here's what the records show. Derechos happen about every few years in the Midwest. But they rarely hit this hard. Since August 2020, 6 more derecho events struck the region. One in December 2021. First December derecho on record anywhere in the United States, 63 tornadoes in one day. Another record. The pattern isn't slowing, it's accelerating. Let's talk rotation. Real rotation. Supercells. These are the thunderstorms that spawn the most violent tornadoes. May 22, 2011, Joplin, Missouri. The tornado touched down at 5:34 p.m. CDT, EF5 rating. Wind speeds between 225 and 250 miles per hour. The damage path, 21.6, 2 miles long. 3/4 of a mile to 1 mile wide at peak, 158 people dead, over 1,150 injured, 2,800 buildings damaged. 4,000 homes destroyed, Joplin High School leveled, St. John's Regional Medical Center gutted, Greenbrier Nursing Home completely flattened, 21 fatalities there alone. The tornado lasted 38 minutes. It carved through the heart of a city of 50,000 people. Damage estimates hit $2.8 billion in 2011. That's $4 billion in today's money. Single deadliest tornado since the 1947 Glacier Woodward F5 that killed 181 across Texas and Oklahoma. May 24th, El Reno and Piedmont, Oklahoma. Another EF5. 9 deaths, 181 injuries. The El Reno Mesonet Station recorded wind gusts at 151 miles per hour. That set a record for the Oklahoma Mesonet, the highest wind speed they've ever observed. And here's the detail that sticks. 3 days before Joplin, the Storm Prediction Center held a special meeting. They were simulating a severe geomagnetic storm scenario. space weather. Then Joplin happened. They pivoted. President Obama toured the city May 29. He delivered the commencement address at Joplin High School a year later. The town rebuilt, but the memory sits permanent. The tornado touched down at 6:23 p.m. CDT. Bridge Creek took the first hit, then Newcastle, then more. The storm followed a 20-mile path. At one point, it was over a mile wide. Mobile Doppler radar measured wind speeds inside the tornado. 302 miles per hour, plus or minus 20. That's the highest wind speed ever reliably measured in any tornado. 36 people dead, hundreds injured, $1 billion damage in 1999 money. Costliest tornado in U.S. history at the time. Then Tuscaloosa, Birmingham in 2011 surpassed it. Then Joplin surpassed that. Then more got hit again. Plaza Towers Elementary School in Briarwood. Elementary both in the path. 7 children died at Plaza Towers, no storm shelters. That detail haunts the aftermath. The tornado was on the ground 39 minutes, 13.85 miles long, over 1 mile wide at peak. 1,150 homes destroyed. The National Weather Service in Norman issued the tornado warning 16 minutes before touchdown. That lead time saved hundreds of lives, but it couldn't save everyone. The 2013 Moore tornado was the most recent EF5 until June 2025, when the Enderlin tornado ended a 12-year EF5 drought. 12 years. That's the longest gap between EF5s since the enhanced Fujita scale started in 2007. But Moore and Joplin weren't the only killers in that era. April 25th through 28th, 2011, the super outbreak, 368 confirmed tornadoes across 21 states. 4 days, 324 tornado-related deaths. 24 more from other thunderstorm impacts. The deadliest part hit April 27th. 224 tornadoes touched down that single day, from midnight to midnight Central Daylight Time. Record, April 27th, killed 316 people. Most tornado deaths in a single day since March 18th, 1925. That was the Tri-State tornado, 751 dead, but April 27th, 2011 came close, and it happened across multiple states simultaneously. Storm Prediction Center identified the threat 5 days out. Issued moderate risk 3 consecutive days, April 25th through 27th. By morning of April 27th, they upgraded to high risk, large portion of the southeast. Alabama got destroyed. 238 tornado deaths in Alabama alone. 69 tornadoes touched down in the state. 15 violent tornadoes rated EF4 or EF5 across Mississippi, Alabama, Tennessee, Georgia. 4 EF5s in 4 days. Typically, you get 1 per year, sometimes none. 4 tornadoes were rated EF5 during the outbreak, 11 rated EF4, 21 rated EF3. 37 violent tornadoes total, third highest number of violent tornadoes in any outbreak, behind 1974 super outbreak and 1965 Palm Sunday outbreak. Tuscaloosa, Alabama, April 27th, 2:50 p.m. Central Daylight Time. EF4 tornado, nearly 1 mile wide at peak, 1.5 miles in some spots. Winds hit 190 miles per hour, 64 people dead. The tornado was broadcast live on multiple television stations. People watched it happen in real time, carved through densely populated areas. Entire neighborhoods flattened. Then it kept going. Struck Birmingham. The track ran through some of the most populated areas in the state. Damage estimates exceeded $2 billion for that single tornado. Costliest tornado of the outbreak. Smithville, Mississippi. First EF5 of the outbreak. 205 mile per hour winds. 18 homes destroyed. Over a dozen deaths. Hackleburg and Phil Campbell, Alabama. Another EF5. 71 deaths. 2 hours on the ground. 75-mile path. Devastated several small towns. The tornado was over a mile wide. Tore through everything. Baymont Inn and Suites near Interstate 75 partially destroyed. McDonald's, Taco Bell, gas stations, all gone. Downtown Ringgold heavily damaged. The tornado came from the same supercell that produced the Rainsville EF5. Alabama accounted for 2,200 injuries. More than 230 deaths, 9 violent tornadoes, 11 total crossed state boundaries. Rural areas hit hardest. Study published in American Journal of Public Health examined Alabama deaths. 247 fatalities total. Females 40% more likely to die than males. Mean age 50.7 years. Youngest 4 days old. Oldest 97. People over 85 were 4 times more likely to die. Rural residents 3 times more likely to die than urban. 92% of deceased were indoors. 54% in single-family homes. 21% in mobile homes. 67% in completely destroyed homes. 7 related to power outages, 4 from house fires, 2 from medical conditions. Oxygen concentrators failed. Insulin couldn't be refrigerated. 1 person fell during the blackout. The National Weather Service issued 303 separate tornado warnings across 6 forecast offices on April 27th. Probability of detection was 0.889. Nearly 9 out of 10 tornadoes were warned. False alarm ratio 0.489. Average lead time 19.9 minutes. That's decent. But when you have 15 violent tornadoes hitting simultaneously, warnings only help if you have somewhere to go. April the 27th, 2011. Costliest tornado outbreak in U.S. history. $10.2 billion in damage. $14 billion in today's money. Second deadliest outbreak since 1936, when 454 died. Narrow bands in the atmosphere that transport moisture from tropics to mid-latitudes. Think of them as rivers in the sky. Some carry more water than the Amazon. The famous one, Pineapple Express. It originates near Hawaii, travels northeast, slams the U.S. West Coast, January 2023. California got hammered. Not one atmospheric river. A series. 3 major hits between late December 2022 and mid-January 2023. The state declared a state of emergency. The atmospheric rivers stretched over 2,400 miles from California to southwest of Hawaii. Winds hit 100 miles per hour near Lake Tahoe. Coastal areas saw 40 to 80 mile per hour gusts. Santa Cruz and San Francisco got 1 to 3 inches of rain in hours. Areas south of Big Sur recorded 6 to 8 inches in 24 hours. The storm caused flooding, mudslides, toppled trees, downed power lines. Phoenix Sky Harbor International Airport issued ground stops. 2-year-old Ayon Tukini killed in Occidental California when a redwood tree crashed through his family's mobile home. 22 deaths total across California from the January 2023 atmospheric river sequence. Worst flooding in recorded history for California, Oregon, and Nevada. The Sacramento and San Joaquin valleys flooded completely. The town of Sacramento sat underwater for months. This was the Great Flood of 1862. Geological research shows megafloods like this hit California on average every 200 years. Some researchers think climate change will increase frequency. The lower atmosphere warms. It holds more moisture. Atmospheric rivers intensify. They stall longer. The damage compounds. Right now, atmospheric rivers cause about $1 billion in damage per year on the West Coast. By 2090, estimates project 2.3 to 3.2 billion annually. It taps into tropical moisture. The jet stream guides the moisture plume. It makes landfall. Orographic lift happens when the moisture hits mountains. The Coast Range, the Sierra Nevada, the Cascades, air rises, condenses, rain or snow falls. Heavy, for days. The ground saturates. Rivers flood. Hillsides become unstable. Mudslides happen. This is how atmospheric rivers kill. November 2006, Puget Sound region, Seattle to Vancouver. Several inches of rain per day. Multiple Pineapple Express storms in succession. Massive flooding in all major regional rivers. Mudslides closed mountain passes. Regional dams hit capacity. Spillways opened to 100%. Officials called it the worst in a decade. December 2010, California again. 15 to 22 December, up to 2 feet of rain in the San Gabriel Mountains. Over 13 feet of snow in some spots. Southern California counties, San Bernardino, Orange, Riverside, San Diego, Los Angeles, all impacted. Mudslides, major flooding, power outages for 50,000. Most powerful storm since January 2010. Bomb cyclones, explosive cyclogenesis. This happens when a mid-latitude cyclone's central pressure drops at least 24 millibars in 24 hours. Some drop twice that. The pressure collapse causes wind acceleration. Rainfall or snowfall intensifies in hours. The storm becomes life-threatening fast. November 19, 2024, Pacific Northwest. A bomb cyclone struck off the Washington and Oregon coasts. The pressure drop exceeded twice the normal bomb threshold, one of the strongest bomb cyclones in recorded history. Hurricane-force winds topped 75 miles per hour in some areas. Mountain passes became impassable under blizzard conditions. The storm destroyed thousands of trees. 450 miles of power lines came down. 600,000 homes lost power. 2 people died when trees fell on homes and cars. Communities took weeks to recover. Most powerful cyclone ever recorded in the Northeast Pacific by central pressure. The system underwent explosive intensification. Pressure dropped 21 millibars in 12 hours, from 964 to 943. The storm shattered multiple pressure records across the Pacific Northwest. Combined with an atmospheric river, the flooding and wind damage spread across western North America. Bomb cyclones typically form in winter when temperature contrast between air masses is greatest. Cold Canadian air meets warm Pacific air. The boundary zone becomes unstable. Low pressure develops. If conditions align perfectly, the pressure drops fast. Bombogenesis. The term came from MIT professor Fred Sanders in 1980. Before that, meteorologists informally called them bombs because they developed with ferocity rarely seen. The Bergen School of Meteorology in the 1940s and 50s started the slang. Sanders formalized it. Now it's official terminology. Northern Hemisphere averages 45 bomb cyclones per year. Southern Hemisphere 26, most hit in respective winters. The four most active regions: Northwest Pacific, North Atlantic, Southwest Pacific, South Atlantic. Rarely do they strike land at peak intensity. Most curve out to sea. But when they do make landfall, the damage spreads fast. Because the pressure is so low, wind speeds spike. Because the system is large, the wind field covers hundreds of miles. And because they move quickly, they give little warning. The November 2024 Pacific Northwest bomb cyclone? Model forecasts showed it would approach 942 millibars. That matched the October 2021 record. The National Weather Service in Seattle confirmed it. Lowest pressure ever recorded off Washington was October 24, 2021. 942 millibars, 27.81 inches mercury. The November 2024 system hit that level. A wall of dust approached from the southeast. Over a mile high, miles wide, it turned day into night in seconds. Visibility dropped to near zero. The haboob originated in southern Arizona around 3:30 p.m. local time. Reached Phoenix 2 hours later. The mechanism? Thunderstorm collapses. Winds blast outward. They scoop up desert soil, build it into a rolling wall. The dust climbs thousands of feet, stretches for miles, cuts the horizon in seconds. Phoenix Sky Harbor. International Airport issued a ground stop. 70-mile-per-hour wind gusts shredded a connector bridge. 60,000 customers lost power, most in Maricopa County. Gilbert, Arizona saw traffic light outages and downed trees across town. Police urged residents to avoid travel. Dangerous conditions everywhere. Common in Arabian Peninsula, also common in southwestern United States. Wind speeds can hit 60 miles per hour. Dust walls climb to 10,000 feet, but they're brief, 10 to 30 minutes typically. Yet dust storms kill. NOAA, Air Resources Laboratory, studied dust storm traffic fatalities from 2007 to 2017. At least 232 deaths in that decade. Daniel Tong, lead researcher, said dust events caused life losses comparable to hurricanes and wildfires in some years. The data proves it. June 28, 1970. Interstate 10 near Casa Grande. 12 fatalities after multiple vehicle collisions. April 9, 1995. Interstate 10 near Bowie. 10 deaths, 20 injured, 4 accidents, 24 vehicles total. July 12, 1964. 8 deaths, 25 injured, 9 cars, 3 trailer rigs, 1 pickup, all from dust storms. Between 2009 and 2017, Phoenix area hospitals recorded 31,133 motor vehicle collision-related trauma encounters. 111 haboob events met meteorological criteria in that period. Study published in the Western Journal of Emergency Medicine. Researchers found a 17% decrease in emergency department visits in the 6 hours following haboob onset compared to before. 235 versus 283. Males made up a higher proportion of injuries during storms. Mortality rates were higher during haboobs. The decrease in overall visits suggests public safety messaging works. People stay off roads. But those who drive face higher risk, and haboobs keep coming. Arizona monsoon season runs June through September. Peak intensity July and August. Dozens of dust storms per year in the southwest. Most don't reach Phoenix Metro. When they do, the city shuts down. The fungus lives in soil. Dust storms lift soil. Logic says more dust equals more fungus exposure. But studies show little to no impact on valley fever numbers. Dave Engelthaler, executive director of Arizona State University's Health Observatory, published research on this. He has over 3 decades studying public health in Arizona, former state epidemiologist, former biodefense coordinator, over 180 scientific papers. His team found no correlation between haboobs and valley fever spikes. The mythology persists. The data says otherwise. What does increase risk? Disturbed soil from construction, agriculture, landscaping, not dust storms. Valley fever cases cluster in Phoenix Metro, Tucson, and Bakersfield, California. Travelers to Southwest who develop flu-like symptoms within weeks of return should inform doctors about their travels. Most people exposed show no symptoms. Most with symptoms don't have life-threatening disease. But it happens. Geomagnetic superstorms. These come from space. The sun releases massive coronal mass ejections. CMEs. Charged particles blast toward Earth. They hit the magnetosphere. Energy floods in. Intense electrical currents develop in upper atmosphere along magnetic field lines. Atmospheric heating occurs. Global magnetic disturbances. These are rare. Once every 20 to 25 years. May 10th, 2024, the strongest geomagnetic superstorm in over 20 years struck Earth. The Gannon storm, named after space weather physicist Jennifer Gannon. The disturbance storm time index hit minus 412 nanoteslas. KP index maxed at 9. That's G5 level, highest category on geomagnetic storm scale. The initial phase occurred May 10th from 1700 to 1800 UTC. Main phase developed May 10th to 11th from 1800 UTC to 0300 UTC. Recovery phase lasted May 11th at 0300 UTC until May 15th. 9 X-class solar flares during those 6 days. Intense solar activity. The outer boundary normally sits 44,000 kilometers above surface. The storm squeezed it to 9,600 kilometers, 1/5 normal size. Japan's RSE satellite launched by JAXA in 2016 captured the compression. First-time scientists recorded continuous direct measurements of plasmasphere shrinking to such low altitude during superstorm. Atsuki Shinbori at Nagoya University's Institute for Space Earth Environmental Research led the study, published in Earth Planets in Space, November 2025. The team tracked changes using a RASE satellite and ground-based GPS receivers. The ionosphere is the source of charged particles that refill plasmasphere. During the storm, extreme solar activity compressed Earth's magnetic field, allowed charged particles to travel farther along field lines toward equator, produced auroras at unusually low latitudes. Auroras typically occur near poles. Earth's magnetic field guides solar particles into atmosphere there. But this storm shifted auroral zone from Arctic and Antarctic circles down to mid-latitude regions, Japan, Mexico, southern Europe, places where auroras are rarely seen. Disrupted planting for many U.S. farmers. According to Terry Griffin, professor of agricultural economics at Kansas State University, farms lost on average $17,000 each. Not catastrophic, but noticeable. Transatlantic flights took more southerly routes to avoid higher radiation exposure for passengers and crew. Also avoided potential communication and navigation losses near North Pole. Satellites experienced power outages. Some stopped transmitting data. GPS systems showed disruptions. Radio communications affected. The storm created 2 extra radiation belts sandwiched between the 2 permanent Van Allen belts. One included protons, unique composition never seen before, discovery important for protecting spacecraft launching into geostationary orbits. They travel through Van Allen belts several times before reaching final orbit. Teresa Neves Chinchilla, acting director of NASA's Moon to Mars Space Weather Analysis Office, said, "We'll be studying this event for years." NASA's Solar Dynamics Observatory observed 82 notable solar flares from May 3rd through May 9th. The flares came mainly from 2 active regions on Sun called AR 13663 and AR 13664. 8 of the flares were X-class, most powerful type. The strongest peaked at X5.8. On May 14th, the same region released an X8.7 flare. Most powerful flare seen in that solar cycle. The first signs of solar storms started late May 7th with 2 strong flares. From May 7th to 11th, multiple strong flares and at least 7 CMEs stormed toward Earth. By one measure of geomagnetic storm strength, the disturbance storm time index dating back to 1957, this storm was similar to historic storms in 1958 and 2003. With reports of auroras visible as low as 26 degrees magnetic latitude, this storm may compete with some lowest latitude aurora sightings on record over past 5 centuries. Scientists are still assessing that ranking. Dolores Knipp, research professor at University of Colorado Boulder's Smead Aerospace Engineering Science Department, said aurora visibility isn't perfect measure but allows comparison over centuries. It's hard to gauge storms over time because technology always changes. The plasmasphere works with Earth's magnetic field to help limit harmful charged particles from sun and space, protecting satellites, supporting natural shielding system against intense radiation. During most intense phase of superstorm, extreme solar activity compressed field. Chemical composition of atmosphere changed due to extreme heating. Reduced oxygen ions that produce particles needed to replenish plasmasphere. Shinbori noted the negative storm delayed recovery by altering atmospheric chemistry and cutting off supply of particles. We hadn't observed this relationship so clearly until now. Geomagnetic monitoring networks spanning the globe. Every storm gets measured. Pressure, wind, temperature, humidity, magnetic field strength, electron density, rainfall rates, storm surge. We build models, run simulations, compare historical data. The storms we're seeing now? Some match historical records. some exceed them. Hurricane Patricia's 215-mile-per-hour winds topped any hurricane measured before. The May 2024 geomagnetic superstorm matched events from 60 years ago, but we have better instruments now. We see details previous generations missed. Does that mean storms are worse, or does it mean we're finally capturing what was always there? Jet stream patterns shifting. All of this affects storm behavior. Hurricanes may not increase in number, but the most intense ones could intensify faster. Atmospheric rivers could carry more moisture, last longer. Derechos could form under conditions that previously weren't favorable. Bomb cyclones could drop pressure quicker. Haboobs could pick up more dust as desertification spreads. Geomagnetic storms? Those follow solar cycles, independent of Earth's climate. But everything else ties back to the same physics. Warmer air holds more water vapor. About 7% more per degree Celsius. More vapor means more latent heat release. More fuel for storms, stronger convection, higher wind speeds, lower pressure drops. All the ingredients megastorms need. That's how many people died globally from natural disasters in 2023, according to the Center for Research on the Epidemiology of Disasters. Storms accounted for a significant portion. Earthquakes too, but storms hit more frequently. They affect more area, they disrupt more lives. And they're predictable. Sort of. We can see hurricanes forming days out, issue watches, warnings, evacuations. We can track atmospheric rivers, model their paths, warn communities. We can identify conditions favorable for derechos, tornado outbreaks, bomb cyclones, dust storms, space weather. All of it gets monitored, forecasted. But prediction only helps if people listen, if infrastructure holds, if emergency services respond, if society adapts. The most extreme ones could increase by 50%. Bomb cyclones may not increase in total number, but the strongest ones will get stronger. Drop pressure faster. Hurricane rapid intensification events already increased. Patricia proved that. 24 hours from tropical storm to Category 5. Cases doubled since the 1980s. The ocean is warmer, the atmosphere holds more moisture. Derechos depend on specific atmospheric setups. But the August 2020 Iowa event happened during below average soil moisture. Drought conditions. Yet 140-mile-per-hour winds still generated. As climate patterns shift, conditions that spawn these events may become more common, or shift to new regions. Days with many tornadoes versus days with few. Volatility increases. April 27th, 2011 had 224 tornadoes. That's clustering. Long, quiet stretches, then explosive outbreaks. The atmospheric ingredients involve temperature contrasts, moisture, wind shear. All changing. How they change relative to each other determines tornado risk. Scientists still debate exact relationships. But April 2011 showed what's possible when conditions align. Haboobs depend on desert soil, thunderstorm outflows. As Southwest experiences drought cycles, more soil becomes available for dust storms, less vegetation, more development removing natural barriers. Phoenix Metro keeps expanding, more people in the path, more infrastructure to damage. If you value this level of detailed research on extreme weather and megastorms, subscribe now. Your support allows us to continue documenting these events with scientific accuracy. Drop a comment telling us which city you're watching from. This script is researched using peer-reviewed sources, including Earth, Planets, and Space, published by Springer Nature in November 2025, the National Weather Service Service Assessment of April 27, 2011, and NOAA's historical analysis of the 1900 Galveston. Hurricane. All facts verified against official records. Now back to the science. The May 2024 superstorm gave us 3 days warning. Maybe. The solar flares started May 7th. The main impact hit May 10th. That's 3 days. Enough time to warn satellite operators, airlines, power grid managers, but not enough time to do much about it. The magnetosphere compresses. The plasmasphere shrinks. The physics happens whether we're ready or not. And here's the part that keeps scientists up at night. The Carrington event, September 1859. Biggest geomagnetic storm in recorded history. Telegraph systems worldwide failed. Some caught fire. Auroras visible in Caribbean, Hawaii. If that happened today, estimates put damage in the trillions, satellites fried, power grids down for months, GPS fails, communications collapse, financial systems can't settle transactions. The May 2024 storm was nowhere near Carrington levels, but it was the strongest in 20 years, and it showed us what's possible. The sun doesn't care about our technology. It follows 11-year cycles, solar maximum, solar minimum. We're approaching solar maximum now. More storms coming, guaranteed. Carbon dating puts them in the 11th century. The Norse tried to control northern trade routes. They pushed into Sami and Bjarmian territory. The locals knew the weather patterns. The Norse didn't. The storm came fast. No survivors from 3 ships, just bodies washed ashore. The locals buried them, left markers, then moved on. 1,000 years later, archaeologists found the site, confirmed the saga wasn't myth, it was documentation. The storm killed them, the sea took them, the earth held them. That's how megastorms work. They don't negotiate. They don't care about your tech, your models, your warnings. They're forces of nature executing physics. Air pressure seeks equilibrium, water vapor condenses, energy transfers, and everything in the path pays the cost. The only question that matters, will you be ready when the next one comes?